says freeze on top right again.
Freeze?
I don't know if that's going to be an issue.
And we'll see.
Well, did you turn on the stream?
Yeah.
If you did, then it says not streaming on the screen, therefore it is frozen.
It is streaming. We are live, which means we're just gonna go. Doesn't matter what's happening over there. That's the difference. It's probably not frozen anymore, right? Perfect, working. All right. A little technology hiccup, like every other day. Let's see. But still, it works. It's awesome, right? I'll start off this class with noting that it's good for bad things to happen once in a while, because they remind you of that you should be appreciating when they're not happening. It's like headaches. I always like headaches. I don't get them too often, and when they happen, I know that tomorrow I will be appreciating not having a headache much more than the day before I had it.
I thought the glass is half full.
So little technology glitch over there. Just reminds me of how awesome this technology is, because otherwise I would be chiseling still, Can you imagine? All of the tablets, the stone tablets that I would have to carry, and the chisel, and I know that's how the writing used to be at some point. I mean, granted that all the professors were ripped because they had to drag all of that stuff with them, right, all the time, but yes, that argument will never go away. Everyone who goes to the gym will die, yes, eventually. All right. Exercise or not. Calculus 1. Welcome to Calculus 1. There was a little intro about life. Welcome to the planet, right? We're going to talk about graphing functions without calculators. So again, this is that wonderful desert island kind of deal. You have no calculator, no computer, no tablet, and you happen to have this function that is supposed to be graphed. So let's see how is that done by hand. It's going to be a procedure. We're going to take a lot of pieces that you learned in algebra and pre-calculus and calculus and put them all together, and have a long list of things that we put on a graph, and then we connect the dots and we have the graph. This is not going to be used for basic functions that you were supposed to memorize, or those basic functions that are just simply shifted left, right, or reflected, or something like that. Those are all basic rules from pre-calculus, and there is no need to use this on easy problems. Just to remind you, so let's say if you have to graph f of x as 1 over x minus 5. So this is a simple shift to the right 5 units. So pre-calculus 1 solves this immediately. You move the vertical asymptote 5 units to the right, and you just draw the function. So something like that can be done with 4.3, but then again, why? Why would you, right? If you can only shift the function 5 units, you're done. Now, what I want to, before we go and do any examples, I want to first take a look at the random graph. So we have something that, I don't know, let's say looks like that. Actually, so that's x-axis, that's y-axis. The first thing that I would say, domain and the range can be observed. Then you have x0 and x1, x-intercepts. You also have this one at y0, y-intercept. You also have this line over here, which is a horizontal asymptote. You also have all the min and max happening. And finally, you also have the intervals increase, decrease, and concavity, concave up, concave down. So we have increase, decrease, and we have concave up, concave down business as well. So as you can see, it's a long list of things. And the great thing about calculus now is that everything on that list you can compute without looking at any of the graphs. You have a function, you are able to do the first and second derivative test, which at the same time give you critical points, which is min and max. At the same time, you're able to take a look with the second derivative for the concavity. From algebra, you can set equation function equal to 0 to find x-intercept, so you can set every x equal to 0 to find the y-intercept. You can use the limit laws if it's not obvious. You can use limit laws to find out the asymptotes, whether it's vertical or horizontal. So all of these courses now, algebra and pre-calculus and calculus, come together in this section for the purpose of graphing the function. And the cool and clever thing about this is that you as a human can do this and graph it, and the computer is not able to do this. Computer still graphs, but the way the computers graph is what? It computes a whole bunch of points, right? And you don't have to go and compute more points than what the resolution of the screen allows you. So when you look at these calculators, the TI 83, 84, they have pretty big pixels, right? So, the older ones. So you just need to make sure that your algorithm is computing the points down to the precision that the calculator can display because of the pixelated screen. So as you can see, the calculators are not able to find this graph, to draw this graph the same way we do. Calculator is literally going to go and compute 100,000 points between the two values you assigned, and it's going to produce a graph, because it's going to start with 1, and then 2, and then 3, and then 4, and then 10,000 pieces later, it has a graph generated. Now, in our case, we find everything on the list, and then we just put it together. The points, x and y, intercepts, they're all points. And the min, max, right, critical, they're all points. You just put them on the graph, and then carefully look at the increase, decrease, and concavity at the same time to fill in the little lines between the dots you put up. So let's take a look at the example of this. Clearly, these examples will take a very long time to do because they have all of the stuff that needs to be done in terms of the list over here. So let's go with something that. So problem 16, to kick off things. F of x is equal to x squared over x squared minus 4. And no, you cannot cancel x squares because of the minus 4. So what are we supposed to do with this? Well, we can find the x and y intercepts. We can find the asymptotes. We can find domain and range. All of that is pre-calculus or algebra. And when we are done with all that stuff, then we go and find the first and second derivative. Some students like to take the first and second derivative right off the bat. First thing that, and then just box it, and then later on, when you need it for the first and second derivative tests, you just recall them. But let's go in with the x and y intercepts first. So for x-intercepts, we set f of x to 0. That should be clear because every time you have an x-intercept like this, y is on the 0 elevation. So by forcing the function to be 0, you will be having the equation which will calculate the intercept. So we have x squared divided by x squared minus 4 is equal to 0. Cross multiply, you can write 0 over 1 if you want to. Cross multiply x squared is equal to 0, from where we get negative 1 and 1. I wrote that as a set. Maybe I should just say x equals. Wait. No, it's x equals 0, not 1, negative 1. Square root of 0 is 0. Good. So we have our first intercept. This intercept is at 0, 0. X-intercept. Now, immediately, if you have 0, 0, must be Y-intercept at the same time. So let's take a look at the Y-intercept. We set x equal to 0, and that will immediately produce y equals 0 squared over 0 squared minus 4 is 0. So we are getting the same point. So we are going to actually box this information because we need it. After we found the intercepts, we jump into vertical asymptotes. Maybe I should be, whenever we start a new piece, maybe I should use this. So now, asymptotes. Vertical asymptote, we set the denominator x squared minus 4 equal to 0, and that gives us x equals plus minus 2. Right? You move the 4 over, you square root both sides, don't forget plus minus. So for vertical asymptote, we have two candidates. Now, if you remember, I told you that setting the denominator equal to 0 doesn't mean that it's vertical asymptote there. You can have situations in which you we'll come back to that, but it cancels. If you remember what was happening earlier, right, in our chapter 2, it was canceling, right? You can factor and you can cancel, and then it's no longer vertical asymptote. It's going to be a point that it's missing, so it's just a hole. So now we have the vertical asymptotes here, and we don't. Why am I not doing the limit here? Because we see that it's not going to cancel. We see that much. So we have the vertical asymptotes at x equals to 2, x equals to negative 2, and I have to box that as an important piece of information. Then we're going to have a horizontal asymptote, and the horizontal asymptote is those growth rates. If you remember the growth rates, you should be able to solve this quickly without going into divisions and so on. But then let's do division. First of all, from pre-calculus, what is the horizontal asymptote here?
The 1 over negative 4.
1 over,
I don't know.
why 1 over negative 4?
Wasn't it when the exponents are the same degree, you divide the
Yeah.
multiple is 1?
So yeah, we can.
Okay, yeah.
What do you have? I'm sorry? Y equals 1, yes. So you can memorize from pre-calculus, right? When they have the same exponent, it's a ratio of product coefficients, But product coefficients are 1 and 1, so 1 divided by 1 is 1. Or you can also do the limit, right? The problem is not asking to prove, so you don't have to go through the limit procedure for the asymptotes. But then you might want to. Maybe that's your Sunday. Nothing else going on.
Who needs football?
I'm sorry?
Is that who needs football?
No one. Let me answer that right away. I had a very lengthy discussion with my Calc 2 class, summer one, about how we could actually enhance football and soccer and these sports so they're actually watchable.
How's that?
I would actually have to pause the stream because it's a highly classified information. It's a highly classified information if you know what I mean. But in some cases, audience would participate as well. We came with really good ideas. I particularly like the one for soccer. Maybe we'll share about it. We'll talk. Let's do the horizontal asymptote. So horizontal asymptote, definitely we have x squared over x squared minus 4. So same exponents leads into y equals to 1, as all of you noted. Awesome. So far we have the x and y intercept at 0, 0. We have the two vertical asymptotes at -2 and +2, and we have a horizontal asymptote at 1. Now slant asymptote, also known as oblique asymptote, happens only in a case when the exponent in the numerator is by 1 greater than the exponent in the denominator. In this case they're the same, so you can't have horizontal and slant at the same time. They're mutually exclusive, so no, I'm just going to put here on the side, no slant asymptote, no SA. All right. Once you have vertical asymptote, you can immediately answer the domain question. Since vertical asymptotes are at ±2, the domain would be what? From -infinity to -2 union -2 to +2 union 2 to infinity. So that's the domain. Not really helpful in this problem, but there will be those ln problems and some other square root problems and so on, where domain does play a key role because it will shorten your calculation. So what else is important? There are other things that we can do, check for symmetry, even an odd function and all of that stuff. Not really necessary because we actually have the first and second derivative test. So let's take those derivatives. All right, so what's the derivative? Anyone? At least tell me the rule. Sure. We all trust him? Which rule do we have to use? Quotient rule, yes. All right, great. I'm just going to box this. And then how about the second derivative? Oops.
use of logarithmic differentiation remedy?
Yeah. Do it. Want to do it on the board?
Would it be 1 over x minus 4x over x squared minus 4?
Possibly. I haven't done it. I'm still thinking about. Actually, I'm contemplating on getting up and getting the paper and doing it on paper, but then I have infinite paper on a tablet, so I'm just gonna write it out because I can. So we have x squared minus 4 everything squared, no, to the 4th, and then we have x squared minus 4 squared times negative 8 minus negative 8x, and then derivative would be, wow, 2x squared minus 4 times negative, no negative, times derivative inside just times 2x. So the second derivative is going to be x squared minus 4 everything squared. There's negative 8 in front. Negative and negative make it a positive 16x squared times x squared minus 4 divided by x squared minus 4 to the 4th. Now you see this one parenthesis shows up multiple times, so we can cancel one of them. So cancel a square over here, cancel this one, cancel this one, put it to the 3. So now what's left? If you carefully look over here, you have negative 8x squared plus 32 plus 16x squared divided by x squared minus 4 cubed. So that's going to be 8x squared plus 32 divided by x squared minus 4 cubed. Awesome. Second derivative. We can still simplify it, but you can kick out 8. So we have first and second derivative. All it's left to be done is the first and second derivative tests. Well, then you have to graph. F dt, first derivative test. So we take the first derivative and we set it equal to 0. So what do we have? Minus 8x divided by x squared minus 4. Set that, wait, is that the first derivative? No, everything squared. So set that equal to 0. When you cross multiply, the denominator completely dies. So we are left with negative 8x equal to 0, from where x is 0. So now we draw and sometimes when you draw these things you will have to be very precise. So what do we have? critical numbers are -2 and 2. And those are the vertical asymptotes. What else do I have? I have 0, 0. And it was the minimum, right? Is it? Who cares? Whatever. Yes, 0, 0. So these are our partitions. Partition at 0 because we calculated it, the first derivative equal to 0, and then we solve the equation. So we have x equals 0 as a critical number. It's going to be either min or a max. And then we also have to use the vertical asymptotes because asymptotes are preserved through taking derivatives, right?
What the horizontal one?
This is, I actually drew this bad. This is not the graph. This is the place where we do the boxes for, sorry. Should have done this, no Y. So the test values for increase decrease, -3, -1, +1, and +3. So those are the, that's partitioning. So remember, partitioning is done through the critical numbers and also through the vertical asymptotes. Because vertical asymptotes are preserved through the derivatives and they stay at the same spot. So now what's happening here? I'm supposed to compute the first derivative x squared over x squared plus, no, that's the original problem. I need the first derivative. All right. So first derivative computed at -3 will tell us whether the function is increasing or decreasing from -infinity to -2. So what is the function for the first derivative is -8x over, so -8x, but x is -3, raised to, no, -8x, that's it, divided by x squared minus 4. So divided by x squared minus 4. So that's going to be -3 squared minus 4, and then everything squared. If you are quick and good with calculators, you can use the calculators, but then if you want the faster solution, then just use a little bit of the brain cells. We're going to notice that the entire denominator is squared, and squares can only give positive values on the other side. So whether you square a positive or negative number, you always get a positive value. So we don't have to worry about the denominator at all because it's squared. And because it's squared, whatever comes out is going to be positive. And over here you have negative times negative is positive. So positive divided by positive is a positive value, which means this is larger than 0, which means function is increasing on that part. Then we do the same thing for -1, and then +1, and then 3. -8, -1, and then negative 1 squared minus 4, everything squared. Again, we do the analysis, the denominator is always squared in this case, so it's non-zero, and you have positive, negative times negative gives us positive, divided by positive, still positive, so we still have increase. Two more to go. F of 1, negative 8 times 1, divided by something squared. I'm not even going to bother writing it anymore, because as soon as you square it, you get the positive value. So this one works out to be less than 0. So the function goes down. And f of 3 is the last test point. It's negative 8 times 3 divided by something squared. We have negative 6, so it's negative divided by a positive, it's negative. So we have one more of these. Now you might ask, well, how is it possible for the function to be increasing and then get to the vertical asymptote and then continue being increasing? It's possible. Hopefully run into a problem that has it. So now we are done with the first derivative test. So now we know where the function is increasing and where the function is decreasing. And whatever the derivative is equal to 0, we have the critical point. Critical points can either be max or a min or inflection. These arrows are not something that you are supposed to memorize, because different problems are going to have different numbers and different behaving arrows. So you can't memorize them all. You have to learn the procedure. So rather learn the procedure, not the actual one problem. Then the procedure says you find the derivative, you set the derivative to 0 to get the critical numbers and then points, and then plot those on the number line, making sure that you do partitioning at every critical value and every asymptote as well. So right now we are stuck with this particular graph that shows 2 increases and then 2 decreases immediately. The only piece of the puzzle that is left is to find the second derivative test. The second derivative test is actually stronger than the first derivative test, because the second derivative test can show concavity, but immediately shows min and max. You don't even have to look at the picture. If something is concave down, then whatever value by that range is going to be a minimum, and so on. So there's a lot of cool things that you can actually catch as you do thousands of problems. If you're doing only 3 problems of homework, don't worry about it. So the whole list over here, everything over here you see is just the first derivative test, where we figure out increase and decrease in these functions. So let's go and do the second derivative test. Second derivative test. We calculated second derivative somewhere. There it is. 8x plus 32 over x squared minus 4. X squared minus 4. x squared minus 4, everything raised to the third power. Much better. All right, so we are again setting this equal to 0. And the denominator just drops because it multiplies into 0. We can factor out 8 and get x plus 4 equals 0, from where we get that x is equal to 4. So at x equals to 4, we have a concavity change. So x is equal to 4. Right? So now that is our inflection. Inflection number, inflection point, if you get the y value for it. And then we do partitioning. Now partitioning, again, this is still the same problem from 3 days ago. We still have the negative 2 and 2 with us. So
Isn't it, when you factor out the 8, isn't it a plus in there?
when I factor out 8,
It's just, no, right, when you would go bounce all to 0. Right, we just did.
here somewhere?
Yeah. You take out the 8.
Oh yeah, it's a plus. So it's negative 4. Thank you. Yep, negative 4. Partition at negative 2. Partition at positive 2. No partitioning here. Good. So now what do? Well, we pick the test points. What are the good test points? Come on. You can't come up with 3 numbers. Did you just say 8? I'm sorry? 3, thank you. And? Negative 3. Do the second derivative test. So f double prime of x is equal to what? 8x squared plus 32. So that's 8, and then x squared plus 32 is plus 4. Is this good? So if you factor, you see, yeah, if you factor this one, oh, you get the plus, not the minus. Okay. And so this should be cubed.
When you draw the number line
Oh,
for the
my
test,
positive. What happened?
when you're drawing the number line for the test, you have to remember to copy the vertical asymptote from the first one.
Yeah, and for the second one. Vertical asymptotes partition as well. So both of them. All right. So I have the derivative written down. And the first thing, the first issue or whatever is to know that it's cubed. Right? Which means you'll have to compute stuff. Because it's cubed. Cube preserves the sign. So if the plus goes in, plus goes out. If the minus comes in, minus goes out. So that cube over there, it's messing things up a little bit, but it's not a big deal. So let's go. Function, second derivative, computed at negative 3. So what do we get? Negative 3 squared, 9 plus 4 is 13. So 8 times 13 divided by negative 3 is going to be, again, positive 9, root 5, 3 root 5. What kind of value is this? Positive. So what does it mean? Concave up. All right, do it for 0 and do it for 3. Oops. Yes?
Explain where you got the numerator x squared plus 4, because above that you use x plus 4.
Yeah.
The second derivative given right here in the box. Second derivative, so I just pulled 8. It's x squared plus 4 left over. And then the denominator stays cubed. All right, awesome. So do. Compute the, do or do not, there is no try. It's a famous quote, right? Who said that? All right, let's go, f of 0 and this one.
Now it's over.
I swear to God, like, they play drinking without having time.
Down at 0 and 3. You guys are good. Well, they don't alternate always.
It don't, but
It happened, they alternate here. Okay, fine. So we have 32, and then we have negative 12. 32 over negative 12 is less than 0, concave down. And then we have for 3, the same thing, right? 8 times 13 divided by 5 cubed. Wait, this is not, this is cubed. My sloppy handwriting. It's not negative 12. But it's still going to be a negative value. Whatever. And this is 5 cubed, so it's again larger than 0, so it's concave up. Awesome. So concave up, concave down, concave up. So we started this problem about 5 pages ago. And we finally have enough information to graph everything.
And it took exactly 40 minutes.
Well, I'm glad that you timed it. We're not done yet because I still have to graph it. So it's going to be 45 for the first example. So here we go. We draw x and y. And we place all of the points we know. And we place all of the asymptotes. So we know there is an asymptote at negative 2, another asymptote at positive 2. There's a horizontal asymptote at 1. So those are all of the asymptotes. We also know, going all the way up and top, that there is a 0, 0 intercept. Great. 0, 0 intercept. Right there. And that's it. Now, to graph this, we have to observe the charts. So we start by increase and decrease. And it says that it's increasing function till negative 2. So to the left of negative 2 is right here, is increasing function, so it should look like this, because it needs to follow asymptotes, okay? And that's increasing. And that piece better be concave up, because the other chart says concave up. Do you see that? It fits. It fits. Remember that I can also draw the increasing piece this way, but that is concave down. There are two ways to draw increasing piece, as a concave up or concave down. The next part, between two asymptotes, we need to have concave down and follow asymptotes, so concave down, following asymptotes. But then I also want to go and check if the increase decrease, right? So sometimes you start with increase decrease, sometimes you start with concavity. And the only way how you can learn that is experience, doing many of these problems. There's no magic formula for which one you should observe. Let's see, it should be increasing up to 0 and then decreasing after it. Yep, increasing up to 0, decreasing after it. Awesome. And the last piece is decreasing and it's concave up again, so that's this piece here. 45? Yes, 45 minutes for a problem. So what do you do when you finish with a 45-minute problem? Exactly! You do another one. Very good. So, guys, we haven't learned anything new today. Technically, what we are doing right now is just reviewing all of the math we learned so far, and then we're placing some dots on the graph and you know, connecting the dots like in a coloring book, you know. I love how they have a segment which says graph rational functions, and then the next segment says more graphing. So here's a good one. X squared ln x. You got this. Go.
Do the whole thing go?
Yeah, the whole thing go. So first thing, x and y-intercept. So set the whole thing equal to 0 and then set x is equal to 0. Then you realize something. So you have that. Do the asymptote. Vertical, horizontal. That should all be good and fast because of the pre-calculus. So let's see how it goes. Maybe you should do this in groups, like talk to people and, you know, support each other. They tell me that how they go to the gym together with packs. But they push each other, right?
I'll just not bother having it.
See the math is your friend, right?
Yeah. I get up in the morning and breakfast is bad.
But hey, so I'm with flash one part.
The more you have, the more money.
Well, the issue is we said
I just don't know if it's actual bug.
What's the problem? Set up debate of some sort, like out. So what would that be? Getting closer. Vertical asymptote, exactly. There we go. It's not
third
beyond.
time's the charm.
Yeah, right. Well, there's also smart testing.
3 options. This cat. Well, try that. I'm sure someone's
Probably looking for it.
you know it's one of his stuff. They came in yesterday. Is it true? That's not a calculator. Research it. You have Donnie on you? What is
got like a really cool asymptote or something. Isn't it the natural log thing that it says
What's the derivative of L and X again?
That's a
It's 1 over X. 1 over X. I get the derivative. You don't know the old sheet. Oh, it's a heck of a horrible. Look at that though. You keep doing that. His goal was definitely to get everyone to move like after the 7 test. Yeah, so they can manage it. Also, they used to do this calc class. More business majors that got trades.
I know. No, they don't. Not in mine, no. Is it who's called?
Yeah, all of them. They used to be in the board. They
Nah, it would have been.
What is it?
Yeah, it would have been just as bad or worse.
This one is what showed every class. Like you should be.
This is how bad is it? Oh, it's pretty bad. Especially calculus. Like I was placed in the calculus and dropped it after the 2 blocks. My advisor stared me in the eyes and was like, "Don't think you could." Serious. And I was like, "Okay." I'm gonna go. Well, she was like, "How good are you at math?" I'm like, "Not bad."
well, the last year.
How many total layers do you have?
What? Yeah, like it says 5 on that syllabus, but like there's no way.
Yeah.
We've done 2 or 3
In 4 weeks.
Yeah. But the last week we had 2 tests, number 3 in the final. I don't know if you took that.
I would almost be able to. Like, how many chapters is it? Is this and then just like.
There's like a few sections that are chapter 4.
4.9.
So there's only 5 sections.
Probably gonna learn like.
5 section 5 and 9 section 4.14.
We already did that. I mean, that was on that was on test yesterday.
Oh yeah. No, we're gonna like learn like any group.
Yeah, we're grade 4.9. 4.9.
That's not right.
Oh, it's well, 13 to 16 every single class. So. Yeah. That is the last of the class. That is the final.
It's gonna be like such a sling. My head is out, bitch.
Just living in a fucking shit.
I've got like a free week before classes start.
Ah, good.
That's it.
That's why I'm not even bothered.
They don't really work anywhere.
Work.
You can go to their store, go to Willie McBride. Partner idea, give me these.
How's it going?
Well, we've had some great conversations, and really, I think that's just
Input pricing.
Let's do the problem.
Oh, but I
Since-
found this calculator in here. It looks expensive. I don't know if this is like for your top 2 students, but
Quite possibly. So we'll see. We'll go with the security. It's not none of that.
it's not claimed in 48 hours.
Yeah. I mean, it's obsolete. To be honest with you, no matter how expensive it looks, because your phones can do more.
That's true.
Your phone can do more than this. It has a better graphics processor, better graphics, a larger screen. Um, your phone will always be better than any one of these with the apps, and you have access to Wolfram Alpha for $5.
I can't use my phone like on the pads. I mean, I can still use
Did
those
you-
kind of calculators for like 3,000 stuff. Like, I mean, you can't use it in here, but.
Yeah,
Wait, what kind of phone do you have?
Galaxy S4.
Just the Galaxy. It's not like really like.
Well, it's their S6 now or something like that.
No,
Right?
7.
7, there you go. Mine is like 3 years old or so. 3 years old, I think. Works fine. There's no need to.
You update?
I eventually will.
No, I mean like update like the
What?
program.
Put in the SD card inside. 32 gig. Give me an hour. We are.
It got to the point where if I want to buy an app, like the updates were too big for the size of my phone. So they do literally make it impossible. Drop it to no.
501.
Absolutely.
What do you have? It works. Let's take a look again at the problem. So the first things we want to calculate are x and y intercepts. So x and y intercept. For x intercept, I'm going to set y equal to 0. So 0 is equal to x squared ln x, which gives us two equations, x squared equals 0 and ln x equals 0, right? So x equals 0, and if x is equal to 1, right, if you eat both sides, so x equals 1. So we have two of these x-intercepts, 0, 0, and 1, 0. But we have to be a little bit careful. You'll see why. Y-intercept, you set all x is equal to 0, so you have 0 squared times ln 0. But ln 0 is negative infinity. There is a vertical asymptote there, and we also know that ln domain is 0 to positive infinity. That eliminates this point because you can't plug in x equals 0. So what we found is that there are no y-intercepts and we also figured out that the domain for the problem, because it is restricted by ln, is 0 to infinity. We also know now that there is a vertical asymptote at x equals 0 because that's where if x is 0, the y try to be negative infinity, so that's a vertical asymptote. There are no horizontal asymptotes here. It's ln. Doesn't have horizontal asymptote. And no slant asymptote. Slant asymptote only exists when you divide the polynomial by polynomial, which are 1 degree apart. Higher one being on top, obviously. So all of this was calculated very, very quickly. So we have the asymptote, we have the x-intercept, and we also have the domain, so we know that we don't have to bother with numbers that are smaller than 0, or 0. We don't have to bother with 0 either. So now we just need to take a look into the first and second derivative tests. So first derivative is we have the product rule, so copy the first times derivative of the second plus copy the second times derivative of the first. So this will be x plus 2x ln x as the first derivative. So f prime of x is x plus 2x ln x. Next is the second derivative right off the bat, so we can have them all on a pile. Taking the derivative, again, a derivative of x is 1, plus, and we have a product rule again, so copy the first one, times derivative of the second, plus copy the second, ln x, times derivative of the first, which is just 2. Clean it up. 1 plus 2 plus 2 ln x. So the second derivative is given as 3 plus 2 ln x. At this point, first derivative test. We are going to start our partition at 0. And we need to set the first derivative equal to 0. So we have x plus 2x ln x equal to 0. So we have x 1 plus 2 ln x equal to 0. So x is equal to 0, but we know we have to throw that away because it's not in domain. Domain starts at 0 without including 0, right? And the other one is 1 plus 2 ln x equal to 0, from where we have that 2 ln x is equal to negative 1, ln x is equal to negative 1/2. To solve this equation, we e both sides, and we see that x is equal to e to the negative 1/2, which is 1 over root e. That is a critical number. And that's somewhere over here, 1 over root e. Oops. So now this partitioned our 0 to infinity domain into two parts. We have to pick two numbers. So now the question is, how much is 1 over square root of e? We can compute that. Let's use the abacus. Should be something around 1 over 1, but let's see. So 1 divided by the square root of e. Oh, 0.60, okay. So approximately 0.607. So the values that we can pick are 1/2 and 1 as test points. Yeah, whatever. We can pick 1, we can pick e. So now we are doing the first derivative test. So first derivative computed at 1/2, and the first derivative computed at 1. So first, where's the first derivative? X plus 2 ln x, 2x ln x. So x is 1/2 plus 2x ln 1/2. This cancels. Ln of 1/2 is a negative number. So 0.5 plus ln of 0.5 is negative 0.19, which is less than 0, which means that for this value here, the function is decreasing. And now we compute the same thing at 1. So 1 plus 2 times 1 times ln 1, which is equal to 1, right? Because ln 1 is 0. That kills the second term. So there is the increase on this side. Awesome. First derivative test done. Second derivative test. Second derivative test is 3 plus 2 ln x equals to 0. So ln x is equal to negative 3 halves. So e both sides. And we get that x is equal to e to the negative 3 halves, which is approximately, let's immediately compute that, 0.22. So partitioning again.
I got a question.
Yes.
We got that critical number. So can we also find out the y value and get a critical point? Or is that-
And that's, yeah, we will have to do that to find the minimum, and yeah, we'll go back to find the point. This one, we see that it's a min, right? But we don't have the y value for it yet. So we'll have 1 over square root of e, and we plug that in the original equation.
Not the derivative, the original equation, right?
The original equation to find y, right? Because your points are always x comma y, not x comma y prime, or, right? So that's why you will plug in original equation, and we'll know that's a min. So 0. Well, actually, I'm going to use the e negative 3 halves and 0. So, believe it or not, the value is 1 over 10, right? 0.1. That's smaller. And 1. So we do the second derivative test. Second derivative computed at 1/10. So second derivative is what? 3 plus 2 ln x. It's 2 ln of 1 over 10. Negative about negative 1.6, which is less than 0, which means what? Concave down. Good. And the second derivative computed at 1. 3 plus 2 ln 1. Well, ln 1 is 0, so the whole thing is just 3, which is larger than 0, which means concave up. Now we're going to find the y value when I plug in 1 over root e in original equation. Oops. 1 over root e. It's going to be 1 over e times ln of e to the negative 1/2. So these guys, right, the negative 1/2 goes in front, so it's negative 1 over 2e. So to get this, plug 1 over root e into original equation. And we have everything. Let's draw. I don't need too much on the left side because we know that there is no function to the left because of ln. We do have these 2 points. So let's see what is this point equivalent in decimals. So what do I have? 1 divided by the square root of e is approximately 0.61, comma, negative 1 divided by 2e is negative 0.18. All right. Now we also have to plug in 0.22 to find this point. That's going to be inflection. So this is our minimum, and this one over here is going to be inflection. Inflection is the point, if you remember the theory from yesterday, inflection is the point where the function changes concavity, and min and max is where it changes increase decrease. So inflection point is going to be computed, again, 0.22 plugged in original equation. So 0.22 squared times 22 is negative 0.07. Negative 0.07. So that's what we have. So if I put number 1 right here, then the inflection point is somewhat here, and the minimum point is over here somewhere. And that's it.
That's it.